good afternoon. My name is Nick Barringer. I work for a company called Puppet Labs. I'm here today to talk to you about how you can use our software to enable DevOps operations within your companies. Now, the software we produce is configuration management software. It enables you to describe the configuration of your nodes and your infrastructure effectively within code, where you can then consistently apply it and also automate the way that you apply it. So the open source solution is called Puppet, and we have a commercial solution too, which is called Puppet Enterprise. So first off, I want to just share with you what I think DevOps is. I mean, DevOps is something you can describe in various different ways. Different people have different opinions about what DevOps really is. But to me, DevOps is, I suppose, derived from this definition I put up here, which came from Wikipedia. I've highlighted some of the words here. And this means that I can draw from this that DevOps, first off, is a methodology. It's a philosophy. It's a way of working, a practice. What DevOps isn't a brand new team of different people that come in to do a different job within a company. And DevOps isn't a nice new shiny solution or tool that you use to work in a different way. DevOps is a subtle changing in the way people in the organization work together. It's a breaking down of the barriers, the invisible walls between development teams, testing teams, operation teams. It's a change in the way they communicate, they collaborate together. We integrate their workflows together as well, so people team across these different silos. And the end goal of all of this is to work effectively, well, more effectively, to produce better software, better services, better products in condensed timeframes. And that's what we get from a successful DevOps implementation. So as we go through the presentation today, I'm going to run a demonstration in the background. And the demonstration is to configure Tomcat and Jenkins onto a Linux node. So I'm going to kick this off now, and what I'm going to do is log on to my console here. Okay. And I'm going to use this to assign a role to a server to be a Jenkins server. Now what we can see here is just a quick overview of the estate I'm managing with Puppet. We can see 10 different servers under management. We can see the health of all the different servers and their last run report down here in the middle. And over here on the left-hand side, we can see a number of classes and groups that we can assign to any given node. Now the classes is a handy pick list of things I can assign. I'm going to go ahead and add classes in here for both Tomcat and for Jenkins. And to make it easy, I'm going to go ahead also and create a group. And this group's going to contain both Tomcat and Jenkins, so I can assign them both together to a single node as one operation. So I'm going to call my group Jenkins Server, and down here I'm going to add the two classes that I've just made available for use through this interface. Now I could go ahead and assign this via a node, or I can do it via the group. Just for speed, I'm going to do it down here, so I'm going to assign this group to my CentOS 65A node. I click on Create, and now it's gone ahead and it's created the group, and it's done the assignment to my CentOS 65A node. Now what I'm going to do now as well is I'm going to, just before I kick it off, go and have a look at this node. And I can see down here information about the node. Its IP address is 10.20.173, and up here I've got a page open to Jenkins on node 10.20.173. There's nothing there. It hasn't got Tomcat, it hasn't got Jenkins deployed on it at this stage. So I go into Puppet here, and I click on Live Management, and I'm going to now tell the Puppet agent on that node to undertake a configuration run, where it will then ask the server, what should I be now? And it will hopefully tell it to become a Jenkins node for me. So there you have it, it's as simple as that. So I'm going to leave this now running in the background. It's going to take at least 5 minutes to do this. So let's go and talk a bit about how Puppet helps DevOps initiatives, and then we can come back later on and have a look and see what's happened to that node. So the way I wanted to put this across today is to really talk about 7 different DevOps capabilities that I think are essential that Puppet provides when you use it in this kind of way. Now the first one here is accessibility. one of the most important things with DevOps initiatives is that people can use common tools across the entire enterprise, right the way from development through QA into operations. And one of the issues with tools are they can be too complicated. So if you're using a complicated tool that's very geared to developers, then when people that perhaps are more used to editing configuration files, using software installers and things like that, come to use them, then it doesn't really work. They don't adopt the tools, maybe they cannot adopt the tools, and the DevOps initiative will fail. Now, an example of this is some Ruby code I've put up here on the board. It's just an example. And Ruby is a fine language for systems administration, but looking at this, it's not particularly readable. You can't tell at a glance what this code does. This code will run to many, many pages. There'll be multiple different files as well, probably, of Ruby code to do an undertaking. And it's bad enough to try and write and maintain this, but to take it over from somebody else, and again, collaboration through the pipeline from development through QA to production means that you do have to adopt other people's code, edit it to your own requirements. Taking this on is not trivial. Let's contrast this with the way that Puppet presents the configurations through our DSL. And what you can see now is markedly different. You're seeing something here it's readable, it's effectively self-documenting. And just to talk you through what we're seeing here, this is to manage an SSH server, and we've broken this down into 3 distinct stanzas. And the 3 distinct stanzas manage just 3 types that are present through the Puppet language. And we can see here a package, first of all, the OpenSSH server. That's being managed, we're ensuring it's present. We can see we've got a configuration file. It's defined where it should be in its file name. We're copying it from a source that's specified, and we can do things like set permissions around this particular file as well. And then we can also see there's a service being defined there. It must be present, and interestingly, we're subscribing the service to the underlying configuration file. If the file changes, the service will automatically get restarted. And likewise, there's precedence and dependency stated there as well. The package must be in place and deployed before we put the configuration file in place. So we've achieved an awful lot with just a few stanzas of code here. And again, it's very readable. There's no barrier to adoption here. This is accessible for all levels, and the training courses for this teach people to do fairly sophisticated stuff with this language in just 3 different days. This leads me on to the second of my essential capabilities, and this is to separate the configuration data from the actual modules that define how things should be installed. So, as an example, let's say we're provisioning a LAMP stack. So we need to manage Apache, we need to manage PHP, we need to manage MySQL, and we need to probably affect the Linux operating system in various different ways. So we've got, on the left-hand side of the diagram there, we've got a depiction of a module, and that module is for managing Apache. And that's all that module will do, just manage Apache. And it will do it in a generic way. The idea being here that you can then compose it together in the same way you saw me compose Tomcat and Jenkins together just now in the start of the demonstration. You can compose it together with the other modules that you need to build a particular type of server. And in this example, you'll have your MySQL, your Apache modules, your PHP, and you may have a number of different modules to adjust and configure the underlying operating system. Maybe a module for the firewall, maybe a module for packages like OpenSSH, but the key thing being that they'll all do just one distinct activity, so they can be reused in this way. And what we'll do is we'll put into those modules parameters, and these parameters enable us to, at the time when the node's configuration is, if you like, determined by the centralized server, these parameters can be looked up. So in this example of code here, we've got a class, my class, and it's got parameter 1 that's present there. Now, if we then go and have a look at where we're going to store these parameters, it's in a key value hierarchy that we call Hira, which is part of Puppet. And we've got this parameter in 2 different hierarchies inside Hira. And the first hierarchy is a common hierarchy, so every node will be able to find that and apply that parameter value when it looks it up. But in the other example, for a particular node web01 in the domain example.com, when that has Hira passed for its configuration, it will instead find the different parameter in that particular hierarchy. So in that way, we can start to define how various different servers will be configured depending on the application, the role of the server, the environment, the data center, for example. And it will then do a completely different deployment, but using one single constant module. So you've got no issues now with having to have multiple versions of the modules, to fork them, to know which one's been applied. You've simply got one distinct version for each technical version of a product that you use, and then you've got the configuration abstracted out of that module. And this leads nicely on to the third point, to manage environments as code. So I've talked to you about Hira, I've talked to you about how you can start to use a module in different ways depending on the configuration requirements for a particular use case. And what you can then do within DevOps is start to define what your environments will look like within this Hira repository. So in this example here, I've got 4 different, we call them data sources, 4 different starting points, if you like, of our repository. And there's one for each of the different environments that we've got. So one for dev, one for production, one for staging, and one for UAT. And this enables us to work in a way that's depicted here on this graphic. We can store a definition for the infrastructure of each environment completely separate to the environment itself. We can have a common root, if you like, for all these definitions. So if you like, you start with a generic environment definition, and then you'll change that depending on how the environments need to differ from each other. So for example, in dev, you may well work with single servers. When you move into QA, you'll work with multiple servers. So the server number will change. Maybe the amount of resources you allocate to them in terms of RAM and things like that will change as well. Maybe the thread model will change too for certain servers. So the key thing here is that the environments just differ where they need to differ, but you have a common environment definition they all draw from. And what this means is, as your code flows through development to QA, to staging, and then into production, it's going through a consistent environment as it does it. And a lot of the pain that comes out when you do things like integration testing is that when you move your developer's code into QA, they may well have changed the configuration of their environments, added packages, patches, things like that, which aren't known about, therefore aren't present within the later environments. And that's when you get failures, bugs are picked up, and it slows things down. You move back into a phase of reverting things back to the developers to find the bugs, to configure the QA environment properly. So by using continuous delivery of standardized infrastructures, you take away some of those issues that you get with differences between environments. This then moves nicely on to point number 4, automation. One of the things with DevOps I mentioned was producing better quality products, services, code more rapidly. And the way to do that is to automate. Now in this example here, we have a Jenkins workflow. It's called build pipeline. And the Jenkins workflow will use APIs to enable Puppet to do the delivery of environments automatically. So these will be defined by your testers, and they will set calls, if you like, stages where environments are provisioned, tests are run. Depending on the output of those tests, the environment may be reset, it may be changed in some way, it may be torn down and re-provisioned. You may move from a small data center environment to large cloud-scale testing. But again, it's all automated. There's no one sitting there having to build servers, to press buttons. You can kick off a workflow and you can wait for it to complete and see what the outcome was. And in this way, you're able then to scale up, not just from tens or hundreds of nodes, but up to thousands of nodes where you need to, for large environments, large deployments, large-scale testing. And these can be data center, these can be cloud, and these can be hybrid environments. Now, in terms of an example of this isn't actually a DevOps example, but it's an interesting one nonetheless. It's a supercomputer environment, which is a joint project in America between the University of Tennessee and Oak Ridge National Laboratory. And they are supporting 16,500 compute sockets using Puppet. Prior to adopting Puppet, they had serious issues rolling out security patches, undertaking just day-to-day system administration on this sort of scale. And automation solved their problems. And there's a case study on our website. If you're interested, go and have a look at that, and it will tell you more about exactly what was achieved. Perhaps a more relevant example, but on a smaller scale, is the way that we work actually inside Puppet Labs ourselves. So this is our QA process, as it was put on the whiteboard by the QA manager for me to have a look at. And what we can see here is Jenkins is present there on the left-hand side, so we've got the automation around the workflow tools inside this environment. What we've then got is we've got OS systems being built up at the top there with our distribution server. At the bottom, we're drawing modules and code from GitHub. We have integrations with our Puppet Forge for our configurations. And then we have, in the middle there, a test harness which runs the whole process. And we're doing various different tests and things like that, both internally and in cloud environments. So we're building up small internal environments. We've got there around about 60 VMs. It will be bigger by now. And then in the cloud, we've got 500 plus VMs being run up for large-scale testing, but automatically provisioned, the tests run, and they're torn down. So it's very quick, and it's very, very efficient. Now, we have a team of 7 people in our QA department for Puppet Labs, and they are now QAing in excess of 40 open source community modules, which are around the Puppet product, which have releases sometimes on a daily basis. And our Puppet Enterprise commercial product has 4 releases per year, patches and everything else on top of that as well. And in terms of their journey to get to having a fully automated, puppetized QA process, they spent a long, hard 6-9 months writing an awful lot of Puppet modules and code and creating what you're seeing here on this whiteboard. But then once they put in the hard work, their job changed subtly. And now they augment their Jenkins workflows, they write scripts, they enhance their modules, and ultimately they push through an awful lot more testing a lot quicker. And Puppet Labs as a company produces an awful lot more releases now. We integrate much more frequently, and we're much more agile. So the same team is still in place, but their jobs have subtly changed. The next essential I want to talk about is using version control. So when you use version control, you can then start to test against different versions. It becomes a lot more easy to deal with the multiple different threads of development that will go on, again, across multiple different products. So we have a module on our website, on our Forge, our VCS repo, and this supports a whole bunch of different version control systems. And what you can then do is you can start to use syntax like this, where we start to look up artifacts actually inside Git itself. So files can be put into Git, Puppet modules can go into Git, and of course your code can be in Git and leveraged by using the integration that we now have in place to draw it from Git. And you can use update hooks as well, so when you change code and put changes into Git, then updates can get pushed to Puppet, so it can then roll those out automatically as well. The next point I want to mention is about cross-team workflows, really the point of the whole presentation I'm giving today. So once you've got all of these things in place, you're then able to go ahead and start to put elegant workflows in place that support the cross-teaming that's previously been very difficult to achieve. And just talking you through this, at the top there in Aquamarine, we have Dev. So the important point here is that Dev, remember we're working with standardized environments. That's all been defined as code. It's going to be the same all the way through. Dev have their standardized environment. They produce the product, the code. And they'll also produce the module that defines how it should be installed and configured. So when Dev have completed that phase and they want to be passed over to QA, they pass not just the code, but also the configuration for the code as well, through to the QA team who are there in green. The QA team will then use the module to deploy the application code. They'll update Hira to take account of different environmental changes they want to make, again, such as running more servers, changing threading models, things like that. And again, they'll run their QA tests in whatever fashion they will do. When they've completed that, when there's a handover to production down there in orange, then they will hand over the code, they'll hand over the updated Puppet modules and configurations. And again, remember, we're using a constant definition of the infrastructure. So again, all the patches, levels of operating system, everything else will be constant right the way through. And production will then take the modules, they'll augment them as they need to for their production environment, and they will then use those to deploy the code. And this solves another important issue as well, which is the disconnect between production, when they're working in completely different environments, with the QA, test, and dev environments, which are internal to the company. And very often, people I've met, I've spoken to them, and they say to me, yes, we get a new code release, we don't get instructions to how to put it live. It's heart-in-mouth stuff, you have to put it live in small hours, test it, change it, draw people from other teams into advice. You don't need to do that anymore because you've got all the expertise packaged up, flowing with the code as it goes on its journey from development through to production. So let's go back now to the demonstration and have a look and see where we're at. So if I now go and have a look back at my nodes view, I can see I've got a report in for my CentOS 65A node. And the report's in blue, and that means some changes took place. And I can click into this and have a look. And we can see, yes, it's got the Jenkins server group assigned to it with the subsequent lower level classes that are included inside that group. And I can also go down and see I've got historic reports here, but I can click and examine what happened on that configuration run in more detail. And if I click in, I can see 17 resources changed. I can see exactly how long it took to perform the various different steps of the configuration process. But I can go into a view here in events, and I can look at everything that changed during that execution of the Puppet's configuration run. And I can see of these 17 things, some of these are installing Tomcat services, Tomcat packages. we're making firewall changes, so on and so forth. And we're also going up there and we're deploying the Jenkins war file. If I now go back to the page I had open that was trying to hit that server for the Jenkins application, and I refresh it, we can now see Jenkins is there available to use. So really that was one single click, and that's provisioned the entire Tomcat and Jenkins software for me. It's made various changes to the operating system. And again, I haven't had to do anything. I could have gone for a coffee. I could have done something more useful. I was talking to you instead. So if we move back now to my presentation, then we can just go through again and just look at the essentials I've drawn out for you today. First of all, accessibility, a common tool that's understandable across the organization. Being able to code, being able to use complex tool sets is not a barrier to entry with Puppet. Abstracting the configuration code from the actual deployment code themselves by leaving the the configuration code, if you like, the deployment code static, you take away risk, you take away problems of needing to fork the various different configurations that you have. Instead, you move to working with the definitions of how things should be installed and configured, completely away from the technical modules that do the work. We've enabled management of the environments, so you can do continuous delivery using the definitions of the environments, and you've now got consistency right the way through the different environments from dev through to production. We're able to use all of this in an automated fashion through workflows, making API calls into the Puppet solution. And we can scale this to manage not just hundreds but thousands of nodes in hybrid environments if we choose to. We can use this with version control systems. We can test multiple different streams of code, and we can join them in multiple different ways, but again based on standardized environment definitions at the bottom of the stack. And all of this supports the cross-team workflows that are so important to successful DevOps. So just lastly in summary here, so Puppet enables you to perform continuous delivery, but it supports continuous integration and it supports continuous deployment. And whilst you don't need to have all of these to have successful DevOps, ultimately they're all important in the level of automation, cross-teaming and success you have with DevOps. So is there any questions here? Nobody? Go on, be brave. There must be a question. Right, the only thing that's not in the enterprise version is the console I've been using. Yeah? So the way I've driven it graphically, that's something that's enterprise only. But when you use open source, you can use all of this, but just with different alternative options as to how you access the configuration. Correct, yes. I mean, you've seen me using Jenkins, for example. That's an external tool. You've seen me using or referencing Git, and that's an external tool. But yes, Puppet is a solution, and you can do all of this. It's in Puppet right now. Okay. Okay, in terms of scaling, maximum number of nodes, it's very hard to say. I mean, the great thing here is that we've got a centralized server, which you can then you can scale it out horizontally behind load balancers if you choose to. You can start to scale it out vertically, and you can break the components apart so that elements like database, like the dashboard servers and things can be hosted on different servers to give you more horsepower. So there's various different ways of getting more performance out of it. And of course, if you ever did hit a ceiling where you found you couldn't go any higher, then you could start, again, a completely new Puppet deployment alongside, which could leverage consistent configuration data. So there's so many ways to grow this. I've never heard of anyone hitting a ceiling they couldn't pass yet. Okay, if there's no more questions, thank you very much.